Okay, in this video, we'll learn how to solve first-order differential linear equations. Okay, before we solve the equation, make sure your equation is in the standard form. So the coefficient of y prime should be 1. Okay? Now, the solution of this equation, y, is going to equal the sum of the homogeneous solution and the particular solution. So the homogeneous solution should be the first step of finding the solution. So the homogeneous solution needs to satisfy the following equation. Okay? Now let's solve this. Let's put this to the right side. So we will get this. If you divide both sides with YH, considering it's not 0, this is the form that we can integrate. So if we integrate this, we will get YH equals constant times this. Okay? Is this the formula for the homogeneous solution? Now, we're going to find the particular solution. Now we're going to use something what's called the variation of parameter method. So what we're going to do is basically change the constant in the homogeneous solution into another function. Now I'm going to put this as r of x, but you can put any kind of function you want. Just we're going to define the r of x later. So change the constant into a function, then bring the rest along without any changes. Okay. Now the particular solution is going to satisfy the original equation. So we're going to put this into the equation we're trying to solve. So y prime would equal r prime minus p of x, r of x. I'll just not write this to save time. So this would be the y prime plus p of x times y, which is r of x times this. Now, these two are going to cancel each other out. Okay, they have the same absolute value but the opposite signs. So we end up with r prime of x times this, which equals the right side q of x. So by multiplying both sides by e to the power of integral p of x, we're going to get r prime x equals q of x times this. Okay, we're going to integrate this one more time to obtain r of x. There we go. We're not going to think about the constant at this moment, the integral constant. Now, the y particular can be expressed as times this. Okay? What I did just now is put the r of x into this. Now, we're done. All we have to do is add these two together, and we will get this, which is the formula for first-order differential linear equations. Now let me write that again. Times. Okay. This is the formula for this equation. Now we're going to solve some practice exercises. Let's start with a relatively simpler one. Okay, so our first step, find the homogeneous solution, where the right side is 0. So YH, if you do the math, we would get this. Now, like I did earlier, we're going to change the constant into a function. So y particular would be r of x times this. Okay, this is called the variation of parameter. Okay, remember that. Now, if we put this into the original equation, we would get this. Now, if you integrate both sides, after dividing both sides by this, we will get this. Okay, so we found out the y particular, which is minus e to the power of x. So the solution would be the sum of these two, which is this. So we found it. Now, unless the initial value is given, the c stays a unchosen value. Unless the initial value is given, c remains a unknown constant. But if the initial value is given, say y equals 0 when x is 0, then the c would be decided. C would then equal 1. So it satisfies this condition. But unless such conditions are given, c remains to be determined. Let's solve one more equation. One more practice. So this time we're going to solve this. When let's give an initial value this time. When y equals 1, when x equals 1. Now, this isn't the form we're used to. So we're going to change this into the form we are used to, where the coefficient of y prime is 1. So divide both sides by x. So we will get this. Okay, for step 1, find the homogeneous solution. Put this on the right side and divide both sides by YH. We will get 2 over x. Now if you integrate this, we're going to get c times x squared. I'm skipping the calculations to save time. I'm not skipping the difficult parts, so you can do it on your own. Now, we're going to find a particular solution, yp. So using the variation of parameter, the c becomes a function and the rest comes along. And if you put this on this equation, we're going to end up with r prime of x times x squared equals x to the power of 4. And then r of x would equal x squared. No. R prime of x would equal x squared, sorry. If you integrate both sides, we will get r of x equals x cubed to the over 3. So we found the particular solution, the homogeneous solution. All we gotta do is add them two together. So we will get this. Now one last thing we need to do is determine the value of c. So since y equals 1 when x equals 1, let's put the values in. So c is 2 over 3. So the solution would be decided into a specific solution, which is this. Alright. Okay, I hope you learned something from this video, and I'll see you next time. Thank you.